Hello friends, in this video let us discuss question 8 of exercise 8.1 chapter 8 trigonometry. Question: if 3 cot A is equal to 4, check whether 1 minus tan square A by 1 plus tan square A is equal to cos square A minus sin square A or not. Let us consider a triangle ABC right angled at B. Given 3 cot A is equal to 4, which gives us cot A is equal to 4 by 3, that is adjacent by opposite, 4 by 3. Using Pythagoras theorem, AC square is equal to AB square plus BC square. By substituting values, AB square is 3 square plus 4 square. AC square is equal to 9 plus 16, that is 25, which gives us AC as 5. Now what is tan A? Tan A is opposite by adjacent, that is 3 by 4. What is cos A? Adjacent by hypotenuse, that is 4 by 5. What is sin A? That is opposite by hypotenuse, that is 3 by 5. Now consider LHS. 1 minus tan square A divided by 1 plus tan square A. By substituting our values, 1 minus 3 by 4 the whole square divided by 1 plus 3 by 4 the whole square. We get 1 minus 9 by 16 divided by 1 plus 9 by 16. Taking denominators common, 16 minus 9 by 16, we whole divided by 16 plus 9 by 16. 16 minus 9 is 7. 7 by 16 divided by 16 plus 9 is 25 by 16. Cancelling out the 16, we get 7 by 25. Now let us consider RHS. RHS is given as cos square A minus sin square A. We have found out cos A and sin A by substituting those values. Cos square A, that is 4 by 5 the whole square, minus sin square A, that is 3 by 5 the whole square. By calculating 16 by 25 minus 9 by 25, we get 7 by 25. Therefore, LHS is equal to RHS, hence proved. This question can also be done without using the numericals. Let us consider LHS using identities. In LHS, we have got 1 minus tan square A by 1 plus tan square A. We can write tan A as sin by cos. So let's write like that. Sin square A by cos square A divided by 1 plus sin square A by cos square A. Taking denominators common, cos square A minus sin square A divided by cos square A, the whole divided by cos square A plus sin square A by cos square A. Can cancel our denominators. Cos square A minus sin square A divided by cos square A plus sin square A. By the identity cos square A plus sin square A is equal to 1, we get our denominator to be 1, which gives us cos square A sin square A minus sin square A divided by 1, which is in turn our RHS, cos square A minus sin square A, equal to RHS, hence proved. As the question gives us the value, we have to use the value and do the sum. If there are no values also, we can do this sum, we can prove it. Thank you.